Welcome to the Explainer, everyone. So if you're tuning into this, you have actually reached a pretty massive milestone. We're talking about the EL1 TEL 309/10 electronics project. This is it, your final year level 300 capstone. And look, I know this can feel a bit overwhelming, but don't worry. We're going to break this massive project down step by step into a completely manageable, totally achievable journey.
400. Yep, that's right, 400 hours. That is the number of study hours you're expected to commit to this project. I know, hearing that number right out of the gate sounds incredibly intimidating. But okay, let's dive into this. Because that massive commitment is actually paced out over an entire academic year. You aren't doing this overnight. It's an intermittent, methodical process of independent study, and today, we're going to map out exactly how you conquer those 400 hours without losing your mind.
All right, here's our roadmap for the Explainer. We'll start with number 1, welcome to your final project. Then 2, preparing for the journey. After that, we hit the big milestones. 3, checkpoint 1, your initial report. 4, checkpoint 2, the interim report. And finally, number 5, the finish line, your final report. Let's get right into it. Starting off with section 1, welcome to your final project, scope and expectations. Let's actually define exactly what this 10-credit level 300 course really means for you and your graduation.
I absolutely love this quote from the official course guide. It points out that this final year project report will likely be, and I quote, the first publication of your research work which you can proudly display on your bookshelf. And, more importantly, it proves that you have earned your degree through your ability and hard work. Honestly, this isn't just another assignment to check off. This is the emotional and academic payoff of your entire degree. It's the bridge between being a student and stepping up as a professional engineering technologist.
Now, let's manage expectations beautifully right here, because this usually brings a big sigh of relief. You are expected to demonstrate an honors-level application of skills, not a postgraduate original discovery. You literally do not need to invent something totally groundbreaking or, discover a brand new law of physics. Instead, you just need to methodically and independently apply the electronics engineering knowledge you've already gained to a real-world problem. It's all about execution, a solid process, and good methodology.
Moving right along to section 2, preparing for the journey, the first few weeks, because independent work definitely requires proactive early planning.
So, the clock starts ticking in week 1. By the end of your very first week, you must find and meet with your project supervisor. Then, by week 3, you need to confirm your project topic and dive right into your literature survey. And actually, here's a fantastic pro tip from the guidelines. Your topic can absolutely be an industrial-based problem from your own workplace. So if you're a working adult, you can literally solve a real issue at your company, which instantly makes those 400 hours incredibly valuable to your actual career. Now, what's really interesting about this is you're going to want to treat the WOS SST project logbook like your absolute best friend for the next year. You really need to develop the habit of making weekly entries. It tracks your progress, highlights the problems you've solved, and honestly, it essentially writes your future reports for you, because all your data is perfectly organized in one place. Trust me on this one, keep an accurate logbook. Okay, you're probably wondering, how are you actually graded? Let's break down the rubric cleanly right up front. Your initial report is worth 10%. Your interim report and oral presentation combine for 30%. And that massive final report, potentially alongside an oral exam, makes up the remaining 60%. This shows you exactly how those expected study hours translate directly into your course marks.
Which brings us to section 3, checkpoint 1, initial report. This is your first major grading milestone, and it's due in week 8.
Taking a step back, this timeline gives us a really fantastic macro view of your entire year. You can see how perfectly paced this is, right? You've confirmed your topic back in week 3, and now we're at week 8 for your very first graded submission on this roadmap.
So your initial report is a relatively concise 1,500 words, but it is heavily structured. You've got to include your project definition, the what, the why, and the how. You also need a detailed project plan and schedule. But look closely at that middle point. The literature review is worth 60% of this specific report's mark. This isn't just summarizing textbooks, okay? It requires a critical appraisal of existing work in the electronics field and explaining exactly how it relates to your chosen project. Moving right along to section 4, checkpoint 2, the interim report. This one jumps us ahead to week 25. So by week 25 and 26, you are deep into the execution phase of your project. And this checkpoint actually has a dual nature. First, you submit another 1,500-word written report. But second, you're also going to deliver a 15 to 20-minute oral presentation to an audience of experts. This proves your midpoint progress in writing, sure, but it also tests your ability to communicate complex technical concepts verbally.
So, the crucial point here is that this interim report is all about proving you're on track. You'll detail your methodology, share your initial results, and outline your remaining plan. But it also serves a highly practical purpose. It helps you secure course-correcting advice from your supervisor before you make that final push. Think about it. If something isn't working, if a simulation is failing, or a circuit design has a fundamental flaw, this is exactly where you flag it and fix it.
And now, Section 5, the finish line, the final report. This is due at week 40, and it's the culmination of your entire year-long journey.
Now, as we saw earlier, the final report is literally the heaviest hitter, making up 60% of your total course grade. But listen to this, because it's an incredibly important rule from the course guide. You must score at least 40% on this specific final report component just to pass the course. So even if you did absolutely perfectly on all the earlier checkpoints, this final document is the ultimate test of your academic capability. Naturally, your final report needs to be structured professionally. It kicks off with a concise abstract and introduction, moves right into your main text, which is where you detail all your methodology, data collection, and analysis, and then it wraps up with your conclusions and recommendations. And remember, logistical details really do matter here. You have to submit a soft copy alongside 2 ring-bound hard copies. So please, whatever you do, don't wait until 3 a.m. the night before when the printer inevitably decides to jam.
Okay, after you submit, there's one final possibility way out in week 46. The oral examination. Now, don't panic, this isn't for everyone. It might be required at the examiner's discretion. Sometimes it's just used to give a student the opportunity to verbally defend their work if their written report was maybe a bit weak, or just to clarify some really complex findings. So stay sharp and definitely keep that logbook handy just in case you get called in.
Well, we've covered the structure, the rules, and the roadmap. Now I want to leave you with this one question to think about. What real-world problem will your 400 hours solve? This highly structured journey isn't just about getting a grade on a piece of paper. It really is your opportunity to step confidently into your career as an electronics engineer and make a tangible impact. So choose a project that excites you, stick to this roadmap, and you're going to do brilliant work. Thanks so much for joining me on this explainer, and good luck.